In this video, we'll look at 3 more problems that you're going to encounter in lesson 5 for today. So one of them being, you'll get a question where it asks you to identify the ordered pair that occurs at the terminal side of the given angle when sketched in standard position on the unit circle. Okay. So this first angle here, so if we have some angle theta, and it's at the location 13 pi divided by 4. Okay, so that's some angle in radians. You could, if you really want to, convert it to degrees, because that's kind of what we've been doing so far. But I want to show you that you can use the unit circle to really easily find this without having to convert it to degrees. Okay, so check this out. This is kind of what I was talking about when I was talking about counting in slices in the last video. Okay. So notice how this has a denominator of 4. So on the unit circle, there's a bunch of other radians that we see that also have denominators of 4. Okay. So check this out. If we actually count by pi over fourths, or we can think of this as just like 1/4, if we count by these, we can get to the value 13 pi over 4. Okay, so that's 1 pi over 4, 2 pi over 4, which just simplifies to 1/2, like 2/4 simplifies to 1/2. The only difference that might confuse people a little bit is that there's a pi here, so it's a little weird doing fractions of pi, but it still works the same way. Okay, so 2/4 simplifies to 1/2, 3/4, 4/4, that's why we get 1 there, 1 pi, 5/4, 6, 7, 8, and we can keep counting 9, 10, 11, 12, 13. Okay, so there's 13 pi over 4, and that's the coordinate point that we land on. So that's our terminal side, this black side that was here, because I've been rotating this whole time. Like our initial side was right here, and I just rotated my terminal side until it got to this position. Okay, so it's asking what's the ordered pair at that terminal side. Okay, this x and y, that's the ordered pair that they're talking about. They're basically just asking for the coordinate point that's located at that terminal side. So I would say that the answer is -√2 divided by 2 and -√2 divided by 2. So that's the coordinate point at that angle. We can also do this in degrees. So 690 degrees is more than 360. So if I subtract 360 from that, so 690 minus 360, I get 330. So this means I went a full rotation around, and then 330 more degrees. So probably somewhere right around there is my terminal side. Okay. So let's check this on the unit circle. So if I do a full rotation around and then go 330 more degrees, my terminal side is going to land right there. Okay, so that's the coordinate point. That'll be the ordered pair at that terminal side. So √3 divided by 2, comma -1/2. Okay, so that would be my answer. All right, another kind of problem you're going to see looks like this. So knowing that cosine of 5 pi divided by 4 equals -√2/2. So we know this already. We can fact check this on the unit circle. So if I go to 5 pi divided by 4, so 5 pi divided by 4, which is right here, if I look at the cosine, which is the x value, it is -√2 divided by 2. Okay, so fact check them, that looks correct. We know this is true. Then we want to write a trigonometric equation. So this right here, this was a trigonometric equation. So we want to make another one of these from the same quadrant that also equals -√2 divided by 2. Okay, so I want to make another trig equation where I get the exact same output. It's also equal to -√2/2. So what could I write here? Well, from this quadrant, from this same quadrant, there's only another place where I see another negative root 2 over 2. It's right here, okay? So how could I write a trig function so that this would be the output, so that it would equal this, okay? Well, I notice that it's still at the same angle. It's still at 5 pi over 4, but now it's in the sine position, okay? It's my y-coordinate. So check this out. If I was to write sine of that exact same angle, so sine of 5 pi divided by 4, it would still give me that same output, negative root 2 over 2. And again, everything that I'm doing here, you can always double check in a calculator to make sure, but that would definitely give me the same output, okay? So that's the trigonometric equation that would also equal negative root 2 divided by 2. All right. And then the last problem you look at asks for what values of theta, so what angles, because theta represents angles, so what angles in radians will cosine of that angle and sine of that angle, so cosine and sine of that same angle, be equal? Okay. Given that the angle is between 0 and 2 pi. Okay, this just means it's between 0 and 2 pi. Which right now, that's what we have. From 0 to 2 pi, those are all of our angles. These are all between 0 and 2 pi. This is just telling me I don't want to go farther. I don't want to rotate more than 360 degrees. I don't want to rotate more than 2 pi, and I don't want to have negative angles in here as well. So that's just what this restriction is talking about, okay? Don't have negative angles, and don't go past 360 degrees, okay? So for what angles will cosine and sine be equal? Well, funny enough, we just found that right up here, right? Like 5 pi divided by 4 was one of those angles in radians where I got the exact same outputs, okay? They were equal. So 5 pi over 4 is an angle in radians where the cosine and sine were equal. Okay, where else? Where else are sine and cosine equal? Okay, so if you're looking maybe over here at pi divided by 4, the sine, which is the y, and the cosine, we get the exact same value. Okay, so pi over 4 would be another angle in radians where they're equal. And then, okay, if we look at 3 pi over 4, it looks really, really close, right? Like these are almost the exact same value, except one is negative and one is positive. So that's not going to work because we want them to be exactly equal, exactly the same thing. So it's not going to be this angle. And same thing over here, it would not be 7 pi over 4, okay? Because one's negative and one's positive. So those are actually the only two angles where sine and cosine are equal.